In this video, we're going to look at the properties of logarithmic functions, which can be used to solve more complicated logarithmic equations. So there are three properties that are named the product rule, the quotient rule, and the power rule. Now, many questions will ask you to go from the simplified form to the expanded form, or they may say write it as multiple logarithms, or they might ask you to go backwards. They may give you the expanded form and say simplify it, which they may also phrase as saying write it as a single logarithm instead. So the rules show that these work for any base that you have. You'll notice that the base never changes for any of these logarithm properties. So if you were using base 2, for example, it will still be base 2 in the other side of the equation as well. So the product rule says that if you have a log and you are multiplying two things together, so variables like x and y, or maybe something like 3 times x, then you can split that up as log of the first part plus log of the second part for the two numbers that were being multiplied. A similar property deals with division. If you have a logarithm and then there's something divided by something else, like x over y or 7 over z, then you can do the log of the numerator minus log of the denominator. And then the last and most important property really is the power rule. This property gets used frequently for solving equations because it's hard to figure out what an unknown exponent is. But this property lets us bring that exponent out front and multiply it by the log instead, and multiplying is a lot easier to solve for. It's a lot easier to figure out what number did they multiply by than it is to figure out what exponent did they use. So here are some examples where they have asked us to expand or to write each expression using multiple logarithms, because right now I have a single log. So we're going to be taking things from the left-hand side, the simplified form, and writing them out as multiple logarithms. So look for multiplication, division, or exponents, and then apply the properties on the right-hand side instead. Now for this first one, I do see exponents, but I also see things being multiplied. I see x squared times y cubed. Since both the x and the y have their own exponents, I don't want to bring the exponents out front first because they have their own different powers. So let's first use the products property to change this to be log base 7 of x squared plus log base 7 of y cubed. Now I can bring the exponent that is only on the x to the front of that term, and I can bring the exponent that's only on the y out front of that term. So this is the power rule. So I'm going to end up with 2 times log base 7 of x, and then 3 times log base 7 of y. So that's what we mean when we refer to an expanded logarithm or writing it out as multiple logs. You'll notice that the base never changes. So if you have log base 7, you should always have log base 7 throughout the entire question. Now for this next expression, it may be helpful for you to remember that radicals can be rewritten using a fraction exponent instead. So we could rewrite this expression as the fraction x over y to the 1/4 power. Because now writing it this way, I see an opportunity for both a power rule and I see the quotient rule. Now this time my exponent applies to both variables, the x and the y, so I actually want to do the power rule first in this case because the exponent is being applied to everything. So bring the exponent out front and change this to 1/4. Now you'll notice this one doesn't have a base written for the log. That's because this means log base 10. So it's important to know that, but it's not really affecting anything we're doing right now. We're just going to continue to use the log base 10 throughout. So I have 1/4 log base 10 of x over y. Now I have log of something divided by something. So we can use the quotient rule to split this up as two different logarithms. The 1/4 is being multiplied by all of this, so I'm going to do this inside of parentheses, and it'll be log of the numerator minus log of the denominator. So this is our expanded form of the same expression up here at the beginning. One last quick example. Again, I do see things being multiplied. I see a 7 and an x to the negative second power. I also see an exponent. But since the exponent's not being applied to everything, we're going to use the product rule first. And natural log is a log with base e. But again, that's not really affecting anything we're doing right now, not while we're just applying the properties. But it's important to be consistent. So I have to keep using natural log as a result. So natural log of 7, and then I'm multiplying. So this becomes plus natural log of x to the negative second. Now I can bring the -2 out front of just the second logarithm because that's only the x had the negative second power, so I didn't want to apply that to the 7 part. So this part will stay as is, but this will become -2 times natural log of x. And if you think about it, there was another way we could have written this original expression. We could have thought of that as 7 over x to the second power, and then you would have gotten the exact same answer when we applied the quotient rule and then brought the exponent out front. So these were quick examples of what to do when they ask you to write an expression out using multiple logs, or they may just say to expand it. Now we're going to go backwards and see what it looks like to go from the expanded form back to the simplified form. So in all of these examples, we can see that we have multiple logarithms, and they're asking us to either simplify them, or the directions may say to write as a single log. So this time we're going to be looking for addition, subtraction, or numbers out front. So addition, subtraction, or numbers out front, and we're going to be writing them instead as a single log with the numbers being multiplied, divided, or moving that number out front up to the exponent position. So for our first example, we do need to have the base of the logarithms match to use these properties, but they are set up to both be log base 6. So my answer will also be a log base 6. And then the rule when you have a log plus a log is that you can multiply these two numbers. So x times 5, or we usually write that the other way around as 5 times x. Next, we have natural log of y minus natural log of z. Remember, these count as log base e. This is just the way we write that log base e. So whenever you have two different terms being subtracted, this is our quotient rule. So we actually write this as a single logarithm, so natural log in this case. And then the numerator is the first number, and the denominator is the number that's being subtracted. So a single log of y over z, not to be confused with natural log of y over natural log of z. Last case, we have multiple properties we're going to apply this time. First, I have a number out front of this expression, so I'm going to move that exponent over. So this is the common log since it does not have a base written, so this counts as base 10. So if I do the fourth power is going to be applied to both the x and the y. So think of it as xy times xy times xy times xy. You end up with x to the fourth and y to the fourth. I'm going to do the same thing with the second expression. I'm going to leave the minus for now. I'm not taking care of that part yet. I want to do the third power of y times z. So you're multiplying y, z 3 times out, and that's going to give you y to the third power and z to the third power. Now, since we do still have common log, the same base on both of these, now we'll take care of the quotient property. So I can make this a single logarithm. And my numerator is x to the fourth, y to the fourth. And my denominator is y to the third, z to the third. But do note that we have some simplifying we can do here because I have y to the fourth over y to the third. So most of those y's will actually cancel out. So to simplify this expression, this would be x to the fourth. And then a single y would be left on top. All of the y's on the bottom cancel because we're taking 3 y's out of both top and bottom, but I still have the z to the third power on the bottom. So that would be the single logarithm, or the simplified way of writing this original expression. Now, all of the properties we applied before always kept the same base. The base never changed from like base 7 to base 3, for example. This is the formula we can use when we do need to change the base from one of the logarithms. So maybe you want to go from base 3 to base 10. Now, most of the time when you're using these properties, it is with the intention of changing to base 10 because that's what we have on most of our calculators. There's a log 10 key. However, there are some cases where you may also want to change it to log base e, which is what we call the natural log. And I tell you here that generally you want to change to the natural log if there's an e somewhere in the equation you're working with. But otherwise, I tend to change to base 10 unless they ask me to use a specific base. So what's important to note here is that whatever base you have does not matter. It's going to go. It's going to become a new base anyways. So whichever base you choose, a is a new number that was not here on the left-hand side. You pick what you want, usually 10, and you put log base 10 of the top over log base 10 of whatever your base used to be. So the base goes on the bottom. The number you were taking log of goes on top. Some questions may ask you to use the change of base formula and then evaluate a logarithm with your calculator. So if that's the case, then we need to change these to base 10 so that we can type it into our calculators. So first I'm going to rewrite this using the change of base formula. So there's going to be a log on top, common log specifically, and a log on the bottom. The base goes on the bottom, and what you were taking log of goes on top. So now I couldn't type this into my calculator. Most calculators do not have a log base 2 key, but they do have log base 10. So I can type log of 7, close the parentheses, and divide it by log of 2, and then you should get a decimal. I'm just going to round this to a few decimal places. You should get something like 2.807, and then it goes on and on and on. So just for approximation purposes, you should get something like this. I encourage you to try plugging that into a calculator on your own to make sure you know how to enter this correctly. For a second quick example, again, I don't have a log base 1/2 key, but I do have a log base 10 key. So I'm going to change this to log base 10s. So I've picked base 10. The base goes on the bottom, so the 0.5. And what I was taking log of goes on top. And if you enter this into your calculator, you should get a decimal approximately equal to -3.585. Sometimes it's not about using a calculator to evaluate it. Sometimes it's just a request to change it to a different base. So in this case, we have a log base 3, but they want the common log. So again, I'm going to be doing log base 10 on top and on the bottom. We have been asked to use that base here. The base number goes on the bottom, the other number goes on top. So we're not evaluating this one. We just rewrote log base 3 using log base 10s instead. A very similar question, they may ask you to change to a natural log. So that's the ln. So I'm going to have a log base e on the top and a log base e on the bottom, but the formula still works the same way. The base goes on the bottom, and then what I was taking log of goes on top. So here we've rewritten a log base 2 expression using only natural logs instead. So that's it for the log properties and how to use the change of base formula to simplify or evaluate expressions. Thank you.